What volume would 20 grams of carbon dioxide occupy at 25 degrees Celsius and a pressure of 105 kilopascal? So we're given here the pressure and the temperature, and we're also given the mass of CO2 gas. So we just have to solve for the volume. And here we can use the ideal gas law formula, which is equal to PV equals nRT, where P is our pressure, V is our volume, N is the number of moles, R is the ideal gas constant, and T is our temperature in Kelvin. So the value of our ideal gas constant that we're going to use in here is equal to 0.0821 atm liter per mole Kelvin. So we just have to convert everything. So our pressure should be in atm, atmosphere, and then our temperature should be in Kelvin. So our temperature here is 25 degrees Celsius. Let's convert this into Kelvin. So that is 25 degrees Celsius plus 273.15. So that is just equal to 298.15 Kelvin. And for a pressure, which is 105 kilopascal, this is just equal to 1.03627 atm. Now we need to solve for the number of moles of CO2. So we need the molecular mass of CO2. So molecular mass of CO2 is just equal to 44.01 grams per mole. We're given here the mass, so we divide the mass by the molar mass so we can get the number of moles. So that would be 20.0 grams CO2 over 44.01 grams per mole of CO2. Grams here cancel out, so we have 20 divided by 44.01, so that is just equal to 0.45 mole CO2. And now we can plug in all of the values to this equation here. So to find our volume is just equal to nRT over P. So V is just equal to the number of moles, which is 0.45 mole, times our ideal gas constant, 0.0821 atm liter per mole Kelvin, times our temperature, which is 298.15 Kelvin, divided by our pressure, which is 1.03627 atm. So atm here cancels out, mole cancels out, Kelvin cancels out, so we're left with liters. So using your calculator, we'll get 0.45 times 0.0821 times 298.15 divided by this one. This is just equal to 10.73 liters. Okay, so that is our answer to this problem. A 23-gram sample of an unknown gas occupies a volume of 12 liters at a standard temperature and pressure. What is the molecular mass of this gas? Again, we will use the ideal gas law formula, PV equals nRT. We're given here the mass of the gas, sample, the volume, and it says standard temperature and pressure. So that means our pressure is just equal to 1 atmosphere, and then our standard temperature is equal to 0 degrees Celsius, which is just equal to 273.15 Kelvin. So we need to find the molar mass of the gas in grams per mole. So all we have to do is find the number of moles first, then so we can solve for our molecular mass. So to solve for the number of moles, N is just equal to PV over RT. So we're given here our pressure, which is 1 atm, and then our volume is 12 liters divided by the ideal gas constant 0.0821 atm liter mole Kelvin times the temperature, which is 273.15 Kelvin. So this is just equal to 0.54 mole. And now we can solve for the molar mass, molecular mass of the gas. So that is just 23.6 grams divided by 0.54 mole. So the molecular mass of the gas is just equal to 44.1 grams per mole. So this is our answer to this problem. What mass of nitrous oxide gas NO2 is contained in 20-liter balloon at a pressure of 110 kilopascal and a temperature of 25 degrees Celsius? So we're given here the volume, the pressure in kilopascal, and the temperature in degrees Celsius. And we need to find the mass. Okay, and to find the mass of NO2 or nitrous oxide, we need to solve for the number of moles first. So we can use PV equals nRT. So this is N is just equal to PV over RT. So let's convert our pressure first. Pressure is equal to 110.0 kilopascal, and we convert that to atm. That is just equal to 1.08562 atm. And then for our temperature, which is equal to 25 degrees Celsius, that is just equivalent to 298.15 Kelvin. So now we can plug in everything. So N is just equal to our pressure, which is 1.08562 atm, times the volume, which is 20 liters, over the gas constant, which is 0.0821 atm liter per mole Kelvin, and then our temperature, which is 298.15 Kelvin. So atm here cancels out, liter, Kelvin, so we're left with moles. And this is just equal to 0.887 mole. And now to solve for the mass of nitrous oxide, let's get the molar mass of NO2 first. So the molar mass of NO2 is just equal to nitrogen, 1 mole of hydrogen, 2 moles of oxygen, 16 times 2, 32 plus. This is just equal to 44.013 grams per mole. And now to solve for the mass of NO2, this is just equal to the number of moles, this one, 8.887 moles times 44.013 grams per mole. So mole here cancels out. So the mass of NO2 is just equal to 39.1 grams of NO2.